Data Science CIKM 2021. We will commence this session with Dr. Yu-Hsuan, who is a machine learning staff engineer at PayPal in USA. Dr. Kuo works on deep learning models, particularly in transfer learning, few-shot learning, and multitask learning for natural language processing applications. She holds a Ph.D. in computer science and engineering from Pennsylvania State University, my alma mater. She did her work with Professor Daniel Kifer and Professor Zhenhui Li on machine learning algorithms in outlier detection and explanation, differential privacy, and computational social sciences. Dr. Yu-Hsuan has publications in top-tier conferences and journals such as CIKM and VLDB and others. She's very passionate about applying deep learning algorithms to solve real-world problems. We're very happy to have you with us today, Dr. Kuo. Please, if you can, go ahead.
Yeah, so good evening, everyone. Thanks, Robert, for having me here. I'm glad to be part of the Women in Data Science event today, and I'm going to share one of our NLP projects that we do in PayPal, the predicting and discovering customers' intents from its techniques and challenges. So, yeah.
We're happy to have you. You can go ahead and share your screen.
Yes. So, let me go ahead. So, can you see my slides now?
Yes, perfect.
Yeah. So, so this is a joint work with my colleagues, and we are from the customer service application team, particularly working on the NLP applications in this customer service domain. Yeah. So let's get started. I'll start with the this overview of our projects and about our backgrounds and some introduction and with the results. So I started working on the customer chatbot data since early 2019. I will first give some backgrounds of the techniques that we commonly use in the NLP field. Then I will share some of the methods for identifying the intents and then show the results and its applications at the end. Yeah, so a little bit about the background here. As we know, label data is very important in supervised learning and in evaluating the performance. However, it is usually not available in the real-world applications as labeling data is labor-intensive and costly. For example, in our case, we will need to train our customer-centered teammates to be familiar with the definition of all of our supported intents, like around 90 intents, and obviously it is not easy. And also for each utterance, we will need 3 annotators to ensure like higher qualities of our label data. So most of the time, we either do not have any label data set or have to deal with very limited label data. So that is part of the reason why transfer learning, meta learning, or zero-shot learning is commonly and widely adopted in the industry to leverage the public data set or the pre-trained models with our limited label data. So a little bit about the background regarding the transfer learning. It is actually a means to extract the knowledge from a source settings and apply it to a different target settings. And there are a few ways to categorize the transfer learning in the current NLP field. Like one way to do this is to see if there are labeled data or unlabeled data in the source or in the target task. Or in this figure, it can be roughly categorized along 3 dimensions based on first, whether the source and target settings deal with the same task. Like same task but different domains, or it is actually different tasks. For example, like learning the language model as a source task, but transferred to the sentiment prediction task. And the second one is it can be categorized by the nature of the source and the target domains, like different domains or different languages. And the last one, the third one is it can be categorized by the order in which the tasks are being learned. So for example, tasks learned simultaneously or the learned sequentially. So here there are 4 instances of transfer learning here. Domain adaptation, cross-lingual learning, multitask learning, and sequential transfer learning instance. Today, I'll focus more on the sequential transfer learning instance, where we learn on one data set and then transfer to the other task. So basically how we leverage the transfer learning with the pre-trained state-of-the-art language model and our downstream tasks as intent predictions. So now let's move on to the topic that I want to share in more details today. So, yeah, so it is common that customers might contact us through the calls or through the PayPal chatbot to inquiry about their transactions, their accounts, their profiles, and looking for refund status, filing for a dispute, or canceling a payment, or querying for suspicious emails and many others intents, right? So actually, intent prediction in virtual systems or the PayPal chatbots actually enable us to provide cost-effective customer service. And the more we feel like the more customer-related issues that can be resolved by our virtual assistants, the less cost our agents will receive and the better conversational experiences our customers can have. So like if virtual assistant fails to correctly capture a large portion of our customers' intents, then obviously it will lead to customers having to call our support agents. This will actually introduce higher costs on our calls and increases the average wait time. For example, it could be a couple of hours for a user to get a response from an available support agent. So identifying and understanding why our customers are reaching out to us is actually highly sought after. So let's move a little bit to the method and the problem. So first, to be more specific, we formulate our problem as a classification problem to predict the customer intent. And also, we turn to use the unsupervised approach in identifying the new intents for our omni-channel platform. This is a platform that will coordinate and unifies the customer care experience. So to tackle this problem, in our early phase, we actually only have some handcraft intents, like 20 intents initially. These intents are defined by our domain experts or product managers. Also, we have chat log data from the chatbot and the transcripts data from the call center. And also, regarding to the data we have very few labeled training data for each handcraft intent. So for example, we might have only 20 examples for each intent at the very beginning. Last, we have a third-party labeled IVR intent data. This is particularly used in the call center. Yeah. So several challenges here. These labeled data usually very noisy due to human error. Second, we can see that the utterance from different channels, like coming to the chatbot channels or coming to the call center channels, might have different properties. Like the IVR utterance are actually short keyword style text, whereas our utterance in the chatbot channels are actually lengthy, cohesive sentences. And for some complicated scenarios, or cases, customers might prefer to give a call instead of through chat or virtual assistants. And so intents in different channels might be a little bit different, but in general, sometimes these intents, they do share some similarities. Yeah, so our objective here is to generate major customer intent with its corresponding training data. Even though we have some initial seed training label data, but we still want to generate more training data for each associated intent. By doing so, we can design action items in the dialog tree in the chatbot system, meaning that designing the responses to all these supported intents. Also, one important application is to use these English labeled data to train multilingual intent models so that we can extend to some other major languages. Yeah, so next I'll discuss a little bit on the method that we use to solve this problem. Yeah, so as you can see the picture, here is a high-level overview of the method we use to identify the intents. So the input is actually a collection of unlabeled utterance from customer queries. Then we will use the model called ChatBot to see if it can be categorized as one of the existing intents. If it is below the threshold, then we further will use the IVR model to see if it can be mapped to any of our IVR intent class with higher confidence. If not, then in the final stage, we will try to do the clustering. We will return to an unsupervised approach. And for each clusters, we have to rely on our domain expert to define the intents and manually select some training examples to represent that intent class. So basically, domain expert will give the definition of all the intent after looking at the result of the clustering. Yeah, so next I'll give more details about two objectives of our project and also its solutions. Yeah, so first one is that our intent prediction model, the ChatBot, basically we fine-tune the BERT model, particularly on millions of chat log data. We see that the top performers are predominantly the BERT model in 2019. Also, BERT is a bidirectional language model, which means that it determines the probability of sequence of tokens or the words occurring in the sentence. And it uses the subword tokenizer with the input vocabulary containing approximately 30,000 subwords. Here we use the base model due to its lightweight in production as compared to its larger version. So BERT is actually a pre-trained on a self-supervised objectives that does not depend on any supervised task. And in our project, we use first pre-training objectives as well as the second pre-training objectives. So for the first pre-training objective, the mouse language model objective, we masked out a few % of input words in our chat data. And then we try to recover or predict those masked tokens. Then we use the second objective, which is called the next sentence prediction, where we learn the relationship between sentences in the conversation and the chat log. After we obtained the fine-tuned version of the pre-training task, we will fine-tune on the intent prediction task by using the pulled output to feed into a softmax layer. So this is a common practice that we have figures in the lab that is showing that it's a pre-training task, and the figures on the right is actually the fine-tuning task. So basically, we leverage these two tasks in training our chatty birds on our particular PayPal-specific chat log data. Yeah, so next, I'll turn to a more ultimate and a more context-aware intent identification method. So basically, we train the chatty bird model on the IVR data set. By doing so, we are able to get an estimate of how many unlabeled utterance can be categorized as IVR intents. So the advantage here is that based on the distributions of the prediction result from the IVR model, we can prioritize which intents to enable next. Right. So the idea is that the intent with top frequencies will be enabled with high priorities accordingly. And finally, for the rest of the utterance that does not belong to any of the intents class, we will leverage the average of the last 4 layers of its pool output as its sentence embedding for the hierarchical clustering. So then the decision maker will define the intent by looking at the clustering results. Yeah, so any question from here?
We have some questions, but we'll keep them to the end.
Okay. Yeah, so then if not, then I will move to some of the results. Yeah, so first, I will be showing some results of our experiments, the evaluation method that we use for evaluating our chatty bird model, and also some of the online metrics that we use after we ship this model into production. Yeah. So first, for the offline evaluations, we use the precision and recall and accuracy on the label data set. These are for offline that we have some label data for each intent. So from the table, we are comparing the baseline models, the bird model, to see how much it improves after fine-tuning. And so overall, it is an average of like roughly around 5% boost in terms of the accuracy. So in the online settings, we will compute the fraction of utterance with predicted intents being confirmed by the customers. Also, some business metrics like how many utterance end up not going to the contact agents, alternatives, or like how many utterance are being covered by the existing intents and so on. So these are considered as the coverage and effectiveness defined by our business team. So this is more considered as the business metrics. However, we usually do have the offline metric first, and then we will also consider the online metric and fine-tune the model weights or the parameters. Yeah. So here I'm just showing some important intent results in our labeled benchmark data sets. You can see that in these tables, we can see chatty bird performs better than the bird model for most of the intents. As I just mentioned, there is a 5% boost in accuracy. And so we are able to achieve around 89% on this tiny label data set. So next, I'll move to the evaluation of our unsupervised intent approach, which is our clustering results. So for the unsupervised task, we actually leverage the qualitative evaluation. For example, here, the number of clusters are actually determined by the decision makers. And currently, we are setting up around like 60 to 70 as our number of clusters. And we are computing the similarity between utterance in a cluster and from different also utterance from different clusters. So basically, we randomly select some utterance from the important intent class. And in this example below, we can see that utterance 1 and 4 are actually closer, and both talking about the credit increase, while the utterance 2 and 3 are similar. Both are talking about the inquiry of the credit installment. Yeah. So after all these steps that I mentioned earlier, we are now having around like 90 intents being supported. And this includes some label training examples that you can see. Just like these examples are all related to PayPal credits in this table, but in the end, we actually look for a finer granularity for the utterance 1 and 4 as one cluster and the rest as the other clusters. Yeah, so to summarize a little bit, we work on the intent predictions task, and this is an essential task in customer service systems. Our objective is to understand why customers are reaching out to us and help our strategists to design response in the chatbot. So with these identified intents and associate training examples to define each intent class, it could be applied to other channels, such as we also have some emails channels, and we do have some community question and answering forums where user can post the questions there. And so these are the channels that could also be applied with our intent predictions. And recently, we also working on some multilingual intent prediction models. And we are actually leveraging this data set to train our multilingual models. Yeah, so I think that is pretty much for the talk today. So I think we are moving to the questions sessions. So any questions?
Thank you very much, Dr. Ko, for this talk. And it's very nice that we got to see how these applications that many of our students and these models that many of our students are working on, how they actually are deployed somehow in the industry in practical applications to solve real world problems for industry. And I think that customer service is a very common system that exists in almost all companies or service providers.